All right. Welcome, everyone. Good morning, good afternoon, and good evening, depending on where you're all joining us from. We're very, very excited to talk to you today about implementing resiliency in a cloud native ASP.NET Core microservices. And this is a continuation from our previous few shows that we did, the live stream that we did. We talked about getting started with microservices. We then looked at how do you do microservices in a production like an environment. And when it comes to microservices, because they're loosely coupled, they work with each other, we have to look at an important aspect, which is the resiliency as well. My name is Nish. I work on the .NET community team, and I focus specifically on architectural guidances on microservices, cloud native apps, and so much more. All right, today I'm very, very excited to have my good friend join me, Vivek. Hi, Vivek.
Hey Nish, happy to be here and super excited for this session. I'm Vivek, Senior Cloud Advocate, Microsoft.
Fantastic.
And
Uh,
and Nish, would you like to
mhm.
introduce our moderators?
Yeah, absolutely. Stacy, hi, Stacy. So everyone out there, please say hi to our moderator, Stacy Cashmore. She's also a Microsoft MVP. Thank you so much for joining us and helping us out. So if you have questions, please feel free to drop in into the comments of the YouTube if you're watching on YouTube or Twitch, and Stacy will be happy to help you and also send us some questions our way where we will be able to answer them live as well. Right.
Cool.
So what are
So
we learning today?
today's as you said, this is the third session of this specific series which we are doing.
Yep.
And in the first session, we did learn about what our microservices are and how to deploy a microservice on your local machine, and also deploy that to a Kubernetes, which is on local using Docker desktop. And last session was pretty interesting, where we deployed a production microservice app to Azure Kubernetes service, and we added a new service called coupon service to it. and
Right.
and basically it was fun to add a new service and making sure how it communicates with other services, and take that service and deploy it back to the Kubernetes. And today's session, as you know, is Learn Live. Learn Live is about Microsoft Learn modules, and you can see the link there, and there is a QR code. You can pick that QR code, and you can follow along with us, or just stay back and watch this and have some
Yeah.
coffee, watch this, what we are doing now. We're going to do it live. And today we're going to cover something really amazing. We added a coupon service, but if there are failures in the coupon service, how do we handle it?
Right.
And what are the ways to handle that and make sure that your app is fault tolerant? And that's what we are going to learn today. Yes, Nish, why don't you
Yeah.
go and detail
Yeah.
about
Yeah.
it?
Absolutely. Specifically, we're going to understand the foundational resiliency concepts. I think if you joined us on the previous episodes, we talked a little bit about health monitoring, which is also one of those aspects of understanding how are we going to write resilient code. So we're going to look at some of the foundational strategies that we can adopt today, and we are going to look at we're going to observe the behavior of a microservice with no resiliency strategy. So we're going to reproduce an environment where there are transient failures, and we're going to look at how the application performance as of today, and then we will go ahead and write some fault-tolerant code specifically on a single HTTP microservice, and because it's important to understand the strategy, and then we look at one aspect of it, that is implementing something on the HTTP requests, right? And then we will go ahead and look at one other concept, which is infrastructure-based resiliency, which is also gaining popularity because of all the cloud-native technologies out there and service meshes and things like that. So we'll look at how we can implement resiliency if we were to use a service mesh as well. So it's a packed content. So I know Vivek said that you can follow us along, but the encouragement here is to be with us, because we're going to do this completely live, and all the errors that you're going to see are going to be live. So sit back, relax, and enjoy how we are going to do this online right now. So
Okay, so we are live and we have moderators. So make sure to say hi to us. And by the way, you can also ask a lot of questions, and moderator is going to answer. And we will also pick some of the questions and answer it here. And that's so say hi to us, by the way. Okay. Cool. And let's start with the introduction, Nish. So,
right.
basically, what we did in last session, so just a recap.
Mhm.
We did deploy a eShop with the containers and deployed this onto the Kubernetes. And then we added a service called coupon service. And the coupon service was newly added with the order service to work with order service. And there is bunch of services which is talking to each other, and that's what this whole project is all about. And today we are going to see, when coupon service fail, what we should be doing from a code perspective and from an infrastructure perspective. So that's what it is. But by the way, this is the architecture, right? So let's review the architecture before we go deep dive into it, Nish. So why don't
Yeah.
you give an introduction to the architecture?
Yeah, quick recap. Microservices is all about decomposing your application into multiple smaller services based on a business boundary. And if you look at on the right side, those are the business boundary identified, and those services are independent of each other. Like if you look at identity, catalog, ordering, payment, they're all independent microservices, and their databases is separate. So you can see that there's identity service which is using a SQL server. There's a basket microservice which is using a Redis cache, and previously we also did the coupon microservice where we used the MongoDB. Again, the one of the biggest benefits of using microservices is to you have the technology choice as well. When you start to decide to build microservice, you can, depending on the business requirement, you can choose your technology stack, because they are loosely coupled. The only way they interact with each other are on a specific contracts, like the endpoints, either through synchronous communication or through asynchronous communication through event bus, or something like that, right? We also looked at the API gateway previously, because that is the entry point for your web applications or your mobile applications to connect to these microservices, because there are multiple microservices and we do not want to expose multiple endpoints to the end user, because then you have to worry about the security of every single service out there. And you have to secure them at every place. And but if you have an API gateway, you can always have one of those endpoints exposed, and you can also have this TLS termination enabled there, so that all the requests that comes from outside of your cluster is a HTTPS request, and then you can terminate that, and you can have an internal request which are completely on HTTP. And one other aspect we touched upon previously was an aggregator concept, where if you have multiple microservices to work and connect and get the data from, then you don't have to, instead of sending a multiple request from the mobile client or a web client, you basically send a single request to the API gateway, and the aggregator from there on will understand your request and connect to multiple services, gather those data, and then respond back. And if it's a frequently connected service, you can also do a caching in that layer, so you can be quick in your response as well. So we have these kind of amazing advantages that we have in this. Then we can go ahead and it's easier to implement the certain things. Now, we talked about it. Now, when we talk about microservices being independent, the biggest challenge that it comes with is that when you have to work with multiple services, you have to understand failures are very common in this kind of an architecture, and that's where we'll go ahead and see how we are going to implement resiliency.
Yeah, I mean, when it is a distributed system, you should expect failures, right? So there are different multiple services, and sometimes if you open in a real world scenarios where you have built microservice applications, uh, you might have 50 different dependencies, 50 service dependencies, and then there is a set of requests going from one service to other service, and if there are failures, how do you handle these failures, and make sure that still you're coming back from that failure and making sure there is continuity of the functionality which you have, right? So that is something which you need to build, and that is what resilience all about. So how do you recover from a failure? And basically, there are two ways which you can do it, and that is the approach which we are taking today in this particular topic, which is from a code perspective, and other is from an infrastructure perspective. And basically from a code perspective, Nish, how do you build that out, and what is the most important things which you need to consider here?
Yeah. So, as you mentioned, there are multiple ways you can write resiliency, and one of the ways is to implement a code-based resiliency. Which what it means is like, if you are making a HTTP, say a client request in the code, at that point of time, you can implement certain strategies or policies to these. And most popular policies that we talk about is a retry policy and a circuit breaker policy, and that's what we're going to touch upon today. For this, if since we are writing in a .NET, we use this library called Poly, which is a very popular library, and it gives you HTTP extensions, and it is built on certain middleware, so you can also configure them at your HTTP client level, so that your subsequent requests and other things can use the same policy once it is applied. Vivek, let's go on to quickly on the next slide as well, which is which we talk about the retry policy. So as the name suggests, the retry policies are nothing but you keep retrying. So you make a request to another service or maybe an external API or something that you want to connect to get the data or information from. You connect to that service and you have a failure. What you do immediately is not report the failure back to the user, because you don't. Sometimes they are transient failures, meaning they're partial failures, or you can be these things can be retried to kind of like to get rid of this. So you go on retrying this. So basically, instead of immediately reporting back to the client that this request cannot be processed, you basically retry at a server level multiple times, and those multiple times when we specify, those can be configured. So you can have a constant saying every 2 seconds you want to retry, or the suggested approach is basically using something like an exponential backoff, which is exponentially you increase the wait time and then retry. And one
So,
of the
so
things.
Nish, when we talk about the partial failures, so
Yeah.
uh, what could be the example? Like if a container is moving from one node to another node, like you're moving a container, or maybe a
Right.
network outrage, or anything else, and any other examples which is there in the partial failures you have?
Yeah, I think that's the right thing that you said. Like when we are doing Kubernetes and pods keeps crashing, maybe the Kubernetes moving things around, or maybe you deployed a new feature or a new release, and so it is Kubernetes trying to switch between your pods, and there could be like transient unavailable of services, right? So and that is those are very common when you start building applications using Kubernetes and things like that. But also like various other services, not just your own service, but you may be reaching out to some other external services. You may be connecting to a database as well, right? Or any other service bus or something external as well, which your thing depends on. And there could be partial failures, and so you basically retry. And Vivek, I was talking about the exponential backoff, which is an important aspect, because if you configure HTTP client to okay, there's a failure, so let's keep hitting it. The other challenge that we will face is the denial of service that you can hit by the server, right? Because you do not want to fire too many things at the server. So what you do is you basically wait and retry. And as you wait, you can also put some jitter logic to kind of go exponentially and retry as well. So these are again from a strategic point of view to look at, and we'll look at from the implementation side of things as well, right? Um, the next policy here, Vivek, is the circuit breaker. And this name obviously comes from the electrical engineering side of things, where the circuit, you have two states, which is the open and the closed state. So when the circuit is open, which means it is not completing, so basically you don't make a connection at all. So imagine if you keep retrying a couple of times, and then in the subsequent request, you do not want to like have a a lot of things pooled up to make requests. Instead of that, yeah, you can set a policy that, after certain retries, I want to keep the circuit open, and then the subsequent request will automatically fail to the end user, saying, okay, that is, there's no service available right now, and then the other service can actually decide what it needs to do with, right? And uh, and and there are like a couple of things, like, specifically in the circuit breaker policies, there is open, there is half open, and there is closed. So what happens is, when it is open, basically no request will be made. When it is half open, after, you can also specify after how many minutes or how many seconds you want to make the circuit kind of closed, so it goes into that half open mode, where it will be retried again. If it's still a failure, you can go back to the open state, and if something is successful, then it goes to the closed state, and it does not become open until the next failure happens, right? So it's a very interesting strategies out here, very simple to understand, but it's very
I'm
important
just
to understand.
I'm just thinking, if you
Mhm.
don't design this properly, you might be inducing uh, denial of service to your own application.
Correct. You're right. Yeah.
Instead of a hacker doing it, you are setting up for failure. So you have to
Mhm.
make sure, while you're using the retry policy, you have to make sure that circuit break policy is also set correctly. So that's something which you have to be very careful while you're developing this strategy as well. Perfect. So coming to the infrastructure, Nish, it's not
Mhm.
that Kubernetes does not provide. Kubernetes provide you the last time as we spoke, the liveness probe and the readiness probes, which is there, where it verifies
Yeah.
whether I can allow traffic to the pod, or whether the pod is healthy or not, whether I should restart the pod or not. So that's something which Kubernetes already provide, and we have to make sure, while we build these two strategies, we have to make sure even that strategy is in place, because you need to make sure that health checks and other things are already in place. But why we have to do this is basically, there is a lot of advantages of using service mesh. So infrastructure based resiliency is built on service mesh, and there are three main areas, advantages, in fact. So if I have to say, one is, the visibility of your services. So there are multiple microservices which are running in your app, and you have to make sure what's happening in these microservices, right? You want to see throughput, their traffic, and how exactly these microservices are behaving and everything, right? And then there is reliability, and most importantly, the reliability is so important from a retry policies, and the secure bake policies which you can apply onto the app through the infrastructure, and then the security which you can add on top of that, to make sure that your app is secure. And by the way, if you see this, till now, when we spoke about code resiliency, which requires you to go, and as a developer you need to make sure that you add code resiliency through making changes in your code base. But infrastructure based resiliency, it's more about managing through infrastructure. There is no need of making changes in the code, which is
Right.
which is specific to the business application, business
Right.
use cases, right?
Yeah, I think the quick thing here is to understand, we are talking about two types of resiliencies, resiliency handling. One is, you can implement, how can you make your microservices resilient, is like, implement them in code. So the moment you say code, I think one thing to remember is, now you have to think about implementing this in every single microservice as well, like every single microservices which is connecting to other microservice, or any external dependency that it depends on. If it's connecting to that, then I think you have to write those things in code. And that is precisely where the infrastructure based resiliency comes into picture, where, if you are in part of a single infrastructure, you can actually write configurations to implement this resiliency instead of writing them in code. So pretty much different, and they are useful in different times, which we will cover about in a bit. I think what Vivek mentioned here is about service mesh is one way of implementing resiliency. So service mesh is not about just implementing resiliency, but it comes with various other features. As you mentioned, there's MTLS enabling. Then there is like you can have a proper monitoring of your entire services within that cluster. You know what is happening. You know how the logs are being traced and all those kind of things. It gives you a lot more advantages when you use service mesh. But one of the features of service mesh is it has this built-in resiliency mechanism that you can
Yeah.
apply to your services, right? Yeah.
True. It also provides you the UI where you can see the dependency graph of these microservices as well. So let me move on to Linkerd, which we are
Yep.
using as a service mesh in this particular example as well. So just to introduce Linkerd, there are two parts to it. One is control plane, and the other is the data plane. And when you install Linkerd on Kubernetes, basically it creates a manifest file of this Linkerd and then installs the Linkerd as a namespace in one of the namespace, and then it creates a controller. And it's bit of control plane is bit of abstract to you. You don't have to be worried about it. It's more of installation things. And data plane is where the interest is, where you can see here there are two pods which is having a proxy LinkedIn Linkerd proxies which is out there. And in Linkerd proxies, which is where you can say that it's created in the infrastructure layer of the application. So what happens is when you spin up a pod with the Linkerd proxy, there are two containers which gets initiated. One is Linkerd init, and the other is Linkerd proxy. And if you can see this, Linkerd proxies are managing the network traffic, and all the incoming and outgoing traffic is going through these different proxies. And that is where the advantage comes in. It is basically looking at the traffic. It is dynamically making the service discovery. It can make these policies of like retry policies, the circuit policies, and other things which are required, like from the security perspective as well. It can secure the app as well. So since it's working through these proxies, it takes care of the complete app and make sure that you're able to use this app and make sure that there is a resiliency added from an infrastructure perspective. And you can also see there is Prometheus and Grafana, which is there in the control plane, where all the metrics and the telemetry data, everything is being collected and is available on as part of the dashboard, where you can view all of these things and make some decisions on various things which you want to take care. But from the discussion perspective, from the resiliency perspective, from coming back from failure perspective, you can apply the proxies onto the apps where you want to make sure there is a retry policy needs to be applied, and take that app and create a profile, service profile, which we are going to show it in the demo as well. Create a profile and make sure that it has been added into the ingress controllers, so that you can make sure that the whole infrastructure is being resilient, and even the in the incoming request is being taken care, and making sure that retry and circuit policies has been applied as well. So all this is happening without code, right? Nobody
Yeah.
is writing code here, and all this is happening dynamically, and you make little bit of changes in the
Right.
configuration files. So that's how
Right.
it works.
Right, and I think this is a very popular pattern called sidecar pattern that we implement, where all the
Yeah.
cross-cutting concerns are actually moved out of your application. So your application is only focused on your business requirements, and it is only serving your business purposes. And all the cross-cutting concerns are moved into a different thing. And with a service mesh, that's what happens is if when you're deploying it into Kubernetes, it becomes a pod next to your own application pod, and it'll handle all those network related stuffs for you. And there are a few questions, Vivek, from our viewers. So, question from Mehmet, who asks, "Which service mesh application do you recommend for .NET?" There is no specific recommendation. Again, I have tried both Istio and Linkerd. They both are great. They both provide their own, good way of implementing. Istio is one of the popular ones. So you can also look at from a perspective when you're building microservices, if you have even other services that are involved, see how easy it is to work with those services too, and then decide on that. There's nothing to do with a .NET app or a Java app or a Node.js in terms of, because these are sidecar implementations. They don't technically come in way of what technology stack you're using, because we're not even going to use any NuGet package or any other libraries within the code, because they are completely out of it. Your .NET code is not even aware of where it's running, what technology it's using, or what service mesh it's using. So that way you can take those decisions yourself, depending on. I think that the important thing to notice there is to understand what offerings Istio provides and Linkerd provides and what you need, and then you can choose. And I can specifically speak for eShop and containers, like the application that we're going to show you today, where we took the approach of using Linkerd. At that time, we had some issues with gRPC and Istio. gRPC as a tech, we were not. It's not about the .NET. It's about the gRPC as tech. We had faced some issues, so we started exploring Linkerd, and we just found it comfortable to use with Linkerd, and then we continue to use that. But it's but I've used .NET with Istio. It just works very well. There's absolutely no issues. So you can, as I mentioned earlier, go ahead and then verify these, and then choose a tech that perfectly fits your requirement. There's another question. What is the difference between Linkerd and Dapper? Very, very interesting question. So Dapper is not a service mesh. That's an important aspect to remember. Dapper is more like your application runtime, although it has similar features what service meshes provide, but they're technically not a service mesh. So it's more like Dapper is more like it focuses more on your application side of things. So you will be referencing a Dapper client in your application, and then writing those internal connections and things like that. And it comes with those connectors for connecting to your messaging systems and things like that. Even so, basically think of it like it is a very similar approach. It uses a sidecar approach. So Dapper is going to sit side by side to your application, and then do what it needs to do. But then your .NET application will be very much aware of the Dapper, and that's how it is. And again, Dapper also focuses on a few things like working with those connectors and things like that as well. So service mesh, it's going to be it's a very different thing. It focuses very different, like from a network standpoint, and Dapper focuses more from an application runtime standpoint. So I hope I just made that clear.
Yeah.
Cool.
That's so. Let's compare the approaches.
Mm-hmm.
The approaches which we are taking, right? So whether we should have a code-based approach only, or should we go for infrastructure only, or should we have both the approaches for making sure that our app is quite resilient, right? So from my perspective, it's basically you need to have both, because the code approach is more of your business logic application side of it, right? And infrastructure approach is basically the infrastructure. So Linkerd is not able to see what's happening in your application side of it, while the code based approach, which is having a view of your application, might not have a view on what is happening at the infrastructure level. So if you set up both, it will help in building a resilient app from a microservice perspective. So Nish, what is your take on this? Like, you
Yeah.
have any
Yeah, I think.
Go ahead.
Yeah, I think when you say both, important thing to remember there is not to apply retry logic on the code and your Linkerd. That's not what we mean by saying you can use both. But I think of a scenario where, let's say, if you are in an aggregator and you are making connections to multiple services, and one of the services failing, let's say if it's a stock price or something like that, and if you implement something on an infrastructure side of it, what is going to happen is it's going to be retried. It is going to, when a circuit breaker fails, it's going to say, okay, that's done, and then it's going to respond back internal server error, right? But when you implement in code, you can also have the handling part of it. Like, for example, if you try for 5 times or 10 times, and then you decide, okay, let's use the cache value, the nearest cache value, and then respond back. So those are business requirements too. Like, sometimes you don't want to fail on your user. So you will pick up the price which is almost closest to what it was available, and then you can respond back. So you can actually make those choices as well. So when you're connecting with an Excel service, and it's not available, you can immediately go back to the cache and respond. So you can make certain choices in business requirement, specifically in terms of business requirements. So those will be beneficial when it goes with code-based resiliency. From infrastructure-based resiliency, think of it more like you're making a database call, and you need to be, there's nothing else you can do. Then you need to be connected to that, or you need to connect to something like a stream data or something like that, where you need to you need to be connected to get a response. And then yeah, it all makes sense. But again, there's no right answer here. It all depends on your situation, circumstance. So understand what each of it gives the advantages, and then implement it. So you can mix it with the code as well. So the big benefit of infrastructure based resiliency is that you can apply the same policy in a Node.js app or a Java app or .NET app, because their configuration, it's all on the proxy or sidecar proxy. So you don't have to write different codes on each, right? So when you, as a business level, you say, okay, I want all my 5 services to have this kind of a policy applied, then you can immediately go and apply that on an infrastructure side. But if you had to apply the similar thing in a code, you just have to write those code in your application. So yeah, those
Yeah.
also come with it,
But
right?
there,
Yeah,
but there are advantages of using
right,
with code as well. So,
correct.
let's go and implement. Even before we implement, you want to see how
Yeah, let's see the application as of today. How does it look like? So
perfect. So let me come back to
so
the
I think you're on the
service
right
I
page.
have.
Yeah. So can you go back to the so in the portal, in the module, there is a step which says about setting up the environment. So if you go to that,
Perfect.
there
Let
is
me
a
go there.
piece
Let me
of
go
code.
there.
Yeah, let's go to do that. Yeah. So it's
So
the
this
second
is
one.
this is the learn module which we are running, by the way. So let me go to the unit 2 where the exercise is.
Yeah. And there you go.
Okay,
So
here.
yeah, that's the magic script, which is going to set up the entire
And that's my favorite
e-commerce
script.
application.
And
I,
if
I know.
anybody is watching this, if you're watching this, you have to go to this path and see what's
Explore the
what's the
script.
magic. Yeah, it's about the script.
Yeah.
So okay,
So
so I just
mhm.
need to copy this and run it in my cloud shell, which you can
Mhm.
invoke through this, and
Yep.
you can run it here. I've already run it because it takes a little bit of time, Nish, to set
Yeah.
this up.
So it takes about
So
15-20 minutes, depending on, like how busy Azure is, to set up your resources. But if you wait for some time, it will set it up. And then what it does is basically it sets up a Kubernetes cluster. It will have all your microservices running in pods, and it will set it up as a single infrastructure where you can, and has a public IP. And from the public IP, you can see the application as well, right?
yeah. So one
So
of the thing, what is different from the last example which we did in the last week is that it installs Linkerd CLI. So that's something which is new here, right? So after the installation, we have already talked about this. So let us go and see where exactly it is, right? So
yeah.
we'll
So
go to this
can you
exercise.
go back to the CLI once? 1 minute. I'll just quickly show the app itself. So here you go. So can you output the deployment URLs? So this
Yep,
can happen. So as your script runs, at the end of the script, I think that you have a spell check there. DEP.
sorry.
Just tab it. Yeah. Press tab. Yeah, it should. Yeah. So these are the URLs where it'll finally configure. So it's a public IP that is generated. You can see straight away. You can see 3 URLs there. One is a SEC, and then there's a web status. So these are all important tools for you for understanding resiliency. One is the health monitoring, which is what we previously showed in our previous demos. So if you haven't seen that, it's on YouTube and Twitch. Please go ahead and check that out. We show how to implement health check and bring in this coupon here. So you can see this is one of the ways where you can there's a monitoring that is happening here. So you see all the services are healthy. And then can you just quickly go on the sec as well, on the sec URL as well?
Yep.
SEQ, yeah. Again, we use sec here because these are running inside the Kubernetes cluster, but you can use any monitoring services for your distributed logging. So we're using sec for now. So it gives you a nice dashboard, and it'll tell you all the events that are happening within multiple services. So imagine if you have a request that is placed from the web. Whatever request that goes through all the microservices, it'll have a trace ID, so you can configure them in that way, and you can trace them back. So we have another live stream about it. So stay tuned for that one as well, where we go into details of understanding how to do centralized logging and tracing. But for now, just understand that these are the tools available to us to understand how we can make code more resilient, right? Our apps more resilient. Yeah. Now you can go back to the e-commerce application, which is set up on your cluster.
Yeah, I'll just log in.
Mhm.
I need to log in. There you
Yeah.
go. Most
Yeah. You can just
easiest
copy the code from there.
copy. I'm bad at copying and pasting.
Yeah. Just that's why we know you're developers, so we can copy and paste it. So yeah, we're using the identity server for this thing. You can go ahead and change it if you want to use Azure Identity for that. Yeah, so it's simple, like where you can buy .NET Swags. It's just a simple app. So when you make an order,
I
it's not
I
going to
don't want to
deliver to
make
your home or
mistake. I
something.
don't want to make mistake like last time. I want to buy
Okay.
as much as I want because I could have discount coupons now.
Yeah.
So I
So
have
click
it.
on checkout. Yeah.
So I'll click on checkout.
Hmm.
Okay. So what we are doing here is we are trying to show you how the service is, and we do the
Yeah.
checkout. We can place the order, and
Yeah.
you can see how we can place it. But what we have to show to you is there is how we can there is a failure in the system, right?
Let's configure
So
failure, right? Yeah.
let's configure
And
it.
yeah, an important thing is to know that we're configuring a transient failure, and that's why we're doing this Easter egg business. Please do not do this in production, and this is not what we recommend how you should test your application. It's just that to show you how to implement transient, how to write resilient code for these transient failures. So we're just doing this. So the trick is to put fail to and then disk 10. So basically, what that means is for whenever you apply discount code 10, fail 2 times, right? So that's what we're going to putting it there. Ideally, it's supposed to be coupon code. Yeah, so it says, we have configured failures for this. So just remove that fail to and then apply this 10. Yeah. So now click on apply, and you can see that
Oh,
immediately it
failed.
says internal server error. Yeah, because we've configured for error. So ideally what we try to do is if we wanted to only fail for 2 requests, and then the third request should be passing, but it's again a transient error that we are trying to reproduce here, right? But what happened on this scenario is that it immediately fails. Like, okay, it's not going to work, right? So now, how do we fix this? How do we make this more transparent to the user? So user need not know about these transient failures. This can be retried behind the scenes. So let's go and implement that change in the code, which will bring in that change as well, right? Okay,
Perfect.
Vivek. So now it's a test time for you to see how you're writing the code.
Yes.
Yeah. By the way, you can go
How
to the
I'm
logs and check it how that plays. But you
this
don't
one,
have to do
right?
it now. Yeah, there you go. Yeah, so you can see the log. It's just configured and the error has happened, right? Yeah.
Yep. Okay, let's go implement it first.
Yeah.
Okay, so we're going to use poly, right?
Hmm.
So let's go and let me go to this. I'm going to this folder, right? Project folder. So let me clear this.
Yeah. So we're gonna implement this in aggregator.
Message file. Am I in the
Oh,
wrong
you need.
directory?
Yeah. You go one more SRC.
Yeah.
No, no. Go to SRC. No, don't do that. Just CD SRC.
I'm
CDSPNet. Yeah, you're outside CDSRC. Yeah,
okay, got it.
and now
Perfect.
type in the old code. Yep.
Perfect. So I'm in
So
the right code, right this thing now, right folder. And then what we will do is we'll
we'll
add
add a
that poly
package.
package.
Yeah.
Okay, we'll add that. So the package has been added.
Yeah. So it's going to take a little bit of time because it's going to, it's on your Azure CLI, so it won't have any caches. So it's going to fetch those things and get it added. So meanwhile, you can go and write these code changes that you need to
Code
do.
changes. So we
Yeah.
need to
Basically, there
make
are two
changes in the
methods.
code. Yeah, we need to make
Yeah.
changes in service collection, uh, web shopping
Extensions.
aggregator,
Yes.
right?
Yeah.
API gateway, aggregator, web shopping,
Hmm.
and extensions, and I'm there.
Yeah. Again, this is a helper class which has those static extensions which you can add it. So there you go. So apply the retry policy. Um, yeah. Again,
Let me
this
come
is
back.
a it's an online code editor which does not come with an IntelliSense. It's something which is baked into the Azure. So make sure you're copying it correctly, pasting it rightly, and the semicolons and braces and all those things to be taken care of.
So
Right.
this is the most important thing. It takes 5 seconds.
Yeah.
It's retry for the 5 times, right? That's what we are
Yeah.
doing.
Go ahead and copy the other code also. I'll go into the explanation of that so that we don't have to copy the circuit breaker policy as well. The right below that, get circuit breaker policy. Yeah. Yeah.
Copied.
Thank you. And save it. And
Yeah, I'll do
yeah,
that. I have
go
one
ahead
more,
and
right?
build this. Yeah. No. Yeah. You need to make these code changes as well. And so why I'm asking Vivek to do this first, because then we have time to explain this code as it is doing the changes, right? So it's on the
So
coupon. So
it's in
we're
the
actually
coupon
implementing in
phase.
one of the services. Yeah.
I'll just
Um,
go here and add it here.
yeah.
Coupon service. This
Can
is
you remove the
fine.
semicolon on the previous?
Yep,
Yeah.
yep, yep, yep. So it's always about semicolons, as I told you last time.
Yeah.
We always miss semicolons, developers, no?
Yeah.
So let's save this.
Yeah. Save
We are
that.
here.
And then, yeah. And I think you need to just add the namespaces now.
Perfect. So namespaces. Let me come back.
Yeah.
Oops.
Go to the end of it and then just so that you don't mess up anything else. Yeah, there you go. So we have code
Namespaces.
comments correctly to where to add information as well.
Yeah, this is where you can add this. The statements are already here, so that's
Yeah, be
good.
sure to save as well. Control S. Yeah.
Yeah, I done that.
And then cool.
And then we
And
go and build it.
yeah. So you can do a build with no restore because we already added the package. So there's nothing else we added there. So yeah, just build this and then come back to that code. So let's go ahead and explain that thing. Um, so what Vivek did right now is basically added two policies. We basically have some helper method called get retry policy. What so Poly library has is interesting extensions that you can add to your HTTP client, which is where we are doing this handle transient HTTP error, and we're saying wait and retry. So we're going to wait so basically we're going to retry for 5 times, but we're going to wait and retry, and the waiting logic is what you see there. It's nothing but an exponential backoff. The jitter logic that we're putting there, we are using the power of 1.5 seconds and the retry attempts, and basically just wait and retry, right? So that's the logic there. You can add more logic to it, make a better logic there if you want to. And then you also have Poly also suppose advanced retry as well, and advanced retry logic as well, where you can actually configure based on the retry budget. But we'll not go into the detail because I think Linkerd is going to do a similar thing. We'll look at that at that time. But if you want to implement that in code, you can do that in Poly as well. The other thing that we are also implementing is basically the circuit breaker policy. As I mentioned earlier, it's basically going to look at 15 tries and then break the circuit based on that. And for every try after it fails, how many seconds it needs to wait before it retries. So that's what we're configuring here. Again, simple things that you added to your extensions. And then eventually what we're doing is we're going and adding these both policies into the HTTP client. And remember, we are actually implementing only on the coupon service. That's about it. And we are not using it for and this is something which we are using in an aggregator. So whenever an aggregator makes a coupon service call, you are actually adding these policies there to make sure it is retried, and it uses circuit breaker when necessary or when as configured to keep it
Yeah,
going.
just to
All right.
be clear that it's we are doing a redirect policies only on the coupon service,
Only on the
right?
coupon service, correct? Yeah.
Yep. Okay.
So I want to go back and
Just
check what the status of it is. So you made a build. Oh yeah. So
um,
you did a good job of copy pasting. You're a very good developer. Um,
yeah.
so
Let me go back to my folder.
yeah.
Right. I think we have done the build and everything. So we
Mhm.
have rest of the things set up. Let me
Yeah,
go
this is just
back.
an explanation that I told already how the coupon client works. So now you can do type popd.
Yep.
Yeah. So you go back to where you were, and now you can. Yeah, I think you need to redeploy the aggregator so that those changes are applied. Right.
This is the one.
Yeah. So what we're doing here is we are using Docker file here, and Docker file is already configured to have those instructions in there to build the .NET project, and then eventually deploy it to a container registry. Not deploying it, basically pushing it to a container registry, and further we will go ahead and deploy back into Kubernetes. So Vivek, for those of our viewers who are coming for the first time, probably want to explain what a container registry is.
Yeah, so container registry is a private repository for hosting your static representation of your application, which is the images, right? When you package your application as image, you take that package and you need to host it somewhere so that I and Nish can use it, share it, right? So basically, I have packaged it, I've hosted on a private registry, but how does Nish access it? So Nish can access it only if it is being shared at one location. So that's the simple explanation of that. So it is private, by the way. So we both are from the same organization, so we can easily access it, and it is all controlled access as well.
Yeah. So when you deploy this for the first time, what exactly happens is, remember that magic script what Vivek was talking about, just copy paste it and everything sets up for you magically. The magic behind that is like, everything that you need to get started with is all created as an image and has been pushed into Docker Hub. So we use a public registry there because it's an easier pull for everybody who's trying this code for the first time. And then when you're making these changes, we are not actually pushing back to Docker Hub because we're not asking you to create a Docker account and things like that there. Instead, the script is magically creating a container registry for you as well. And whatever code change was done here, basically that image alone was built in container registry, and it will be part of your container registry. Now, the script that he's going to make a change, Vivek is going to make a change now, is to tell Kubernetes that this time the aggregator image shouldn't be pulled from a Docker Hub. Instead, it's going to pull from a Azure Container Registry of your subscription, which is what has been configured. So there you see eShop learn, whatever is a random number .azure.cr.io. That's
This
the
one,
container
which is
registry.
there.
Yeah.
This one.
And to access these images, you obviously have to be on a secure line. So you need to have authentications properly to do this. So because this is a private container registry, unlike a public registry where you can easily provide an image and pull it, this is a private container registry, right? So yeah, what are you doing next now? You're going
So
and
I'm
deploying
just
this to Kubernetes?
deploying this onto Kubernetes, the image which we built now,
Okay,
and we have already set the environment variable for the
cool.
container registry, right?
Yeah.
So let's go
And
back to
and yeah, so what we're doing here is we use Helm under the hood for deploying, installing, and uninstalling, services from Kubernetes. So you may want to explain Helm as well, Vivek. I know we did this last time as well. but I think it would
Yeah, so,
go
so
for
it's
people
just a
running.
package manager. So you want to manage all those different YAML files, which is part of your application, and you want to make, you want to bring up bring all these YAML files together up. So you want to make sure that you package it properly, and you want to use it and also you can share that as a distribution, right? So for example, if you're installing some open source project, it might have 3 to 4 YAML files, and you really don't want to go and find different YAML files. Instead, you package it as a Helm and you version it as one package, and you can share it, and multiple people can use the same version of Helm charts. That's what I meant. So that's what it is. While these things are getting created,
Can you do a
at
kubectl get pods? Yeah,
kubectl pods.
yeah,
So it's all running. So, but
yeah. This
before
is something you need to make sure that everything is running. Yeah, go back to your health check and yeah, refresh the
I
health check
will,
for a minute.
yeah, we will have to wait for the health checks to come back
Yeah.
and
So
report
these are important
everything
things.
is
You
fine.
can see that all the other microservices are running fine because we redeployed aggregator. It's taking time to come back up. So one, the pod has to come up, and then once the pod comes in, it has to expose the endpoints and then configure a few things and then come up. So again, this is one thing to look at for understanding how your services are performing. Yeah. It's going to take, I think, a few more seconds for it. Um, uh, meanwhile, I'll take a few questions here. There was one question on how to implement load balancing for microservices. Vivek, do you have a opinion on that?
Y- Yeah, so you could do it with the cloud providers load balancing for each of the container pods which you have, containers which you're running. You can provide those details there in the YAML file. You can set it up with the service, and otherwise you can also use uh, these ingress controllers and other things which is out there to make sure that load balancing can be managed through that as well.
Yeah. So I think there's also they mentioned that it's a topic in itself. Yeah, it is because load balancing. If you were to do it, yourself, it's going to be a lot of scripts. Instead, I think the way to look at it is like for example, if you're using Azure and Kubernetes, you can look at something called as Azure Application Gateway. You can implement that, and Azure Application Gateway also provides AGIC, which is Azure Gateway Integration. I think it's the ingress controller, AGIC. So you can configure that ingress to be on the from the Azure Application Gateway, and then you can configure load balancing rules on that as well. So you can do a few things like that. Okay, so is our application is back?
Yep, I think all
Okay,
the health check is done, and I'm back
okay,
on the shop.
yeah,
I'm checking it out.
yeah. Can you configure
So
it again because it may be an in-memory configuration? Yeah,
you want me to configure again?
yeah. Just to
Cool.
fail to. No, no, just be there
Just
and then
remove.
just go and say no, 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 no. Just go ahead and write fail to and
Oh yeah,
uh,
I'm doing that.
okay,
So fail to
space to
disk 10, correct?
correct. Yeah,
Apply.
yeah. There you go. And then now you apply disk 10. No, no, just go ahead and apply disk 10.
Oh, sorry.
Don't try fail. Yeah. Now, so previously you noticed that internal server error was immediate. Now, when you click on apply, now watch that. There was no more internal server errors. It automatically applied $10 because behind the scenes, if you go back to the health check, sec, go to the SEQ, the yeah, there you go. So you can see that there's a retrying logic in 1.5 seconds, and then when it was successful, it's applied. So the end user almost did not see it. The ideal thing to do there was to put a progress bar there. We didn't do it, so you can do it if you want to. But then yeah, you could just go ahead and apply this that way, right? Okay, now Vic, let's go back and configure a little more stuffs. I don't know if you notice one thing. um, we actually started from the point where we left off, right? That means all the other microservices were working. So it knew, the basket service knew that you had things in your Redis cache. The order service knew where you were at the point of it. And then when the aggregator was changed, none of those things mattered because they were all independent of each other. So So that's a beauty of again microservices when specifically when you think about building large applications, right? Cool.
Do you want to
So
see circuit breaker? What?
yeah.
What?
So what do we need to do to get a circuit breaker working?
Go to the checkout and do
Mhm.
what, Nish? Like what should I do?
Just configure maybe 20 or something like that. Di,
Fail 20
yes, yeah, and
and
space disk
this
hyphen 10.
10.
Yeah,
So basically, what we're trying to
click
do is
apply.
we're going to induce 20, uh,
Mhm.
20 tries.
Mhm.
By the way, we have configured only for 15, right?
Yeah,
The
click,
in the retry logic.
correct. Click
So
apply.
if I click apply again, or should I remove
Just
this
no
fail
do the yeah.
and make sure
So
and I don't do that?
click
Let's do
apply.
this.
Yeah. So basically, it's going to retry for a couple of times, and then once that threshold is done, it is going to start failing from there on. So go back to sec. Maybe you can see it there. You can see multi.
Yeah,
Okay,
it's
there you go.
happening.
So yeah, so you
There's
can see that
multiple things
multiple.
happening.
Yeah.
Yep,
So there you go. So now there's an internal server. So if you go back quickly,
and
quickly,
apply.
apply again. Yeah, so that's what is happening here behind the scenes. Ideally, what's going okay, now it's doing a retry thing. So I think with the time we configured for the circuit breaker to come back and make it close was too small. So ideally, when the circuit is open, it won't be doing the retry at all. So it will immediately tell the internal server. So basically, again, these are kind of configuration that you can do. Yeah, there you go.
So I can keep clicking on this and sometime it will apply. No, it
Yeah,
won't. Yeah.
right
Cool.
now it won't because the way it is applied is not correctly done. So that's why you can actually configure it correctly to make sure that once the circuit is open, you don't want to make any more retries, right? You can chain it that way.
Perfect. Let,
All right.
let's go to let's go to infrastructure then. So
Yep.
we are done with the how we should be doing this through code, but now we
Mhm.
will see how we can implement infrastructure.
Yep.
Right? Let's go to infrastructure. The first thing we need to do is
We
to
need to roll back what we did.
roll back, right? So
Yep.
let us roll back. Uh, let's roll back. This is a script to
Yeah.
roll back.
Yeah. So the trick there is basically it is we're having that script is taking a registry as a key, as a variable. So when you put eShop dev, it automatically falls back to the Docker Hub images. So whatever we did right now in the code is being rolled back because you won't be able to see the difference if you start applying it on Linkerd right now, right? So yeah,
So let me go back to health check and see if it is all up.
yeah, it's going to take us some more time for it to
Some
come
more
back up.
time to come back.
Yep.
So while it's happening, we can
Let's do the
just
Linkerd. Yeah.
yep.
So we
So
have already. Mhm.
so we have the Linkerd is. I mean, when we did the setup, Linkerd CLI was installed already. So we just have to pick that up and see whether all the prerequisites for setting up the Linkerd is there. It Linkerd provides you know wonderful command, the check prerequisite command. Let's run it and see what it shows. So it's basically checking all the things which is Kubernetes infrastructure is all set for setting up the Linkerd on it. So these are the couple of things. It is checking for the Kubernetes version and couple of things on the control plane.
Yeah, it's basically
And yep,
checking your infrastructure to see if it is capable
yep,
of installing it, right? So
yep,
it's just a pre-check.
pre-check.
Um,
So I'm not sure. We can go ahead and install.
mhm.
No, we have
Yep.
the service yet. Let me check the
You can do that.
service.
So I think it should be fine.
Uh, I don't want to test something on the live. So let's hope the service will come back up faster so that we can go back and configure Linkerd on these things. While this is happening, let me explain things as well. So what we're going to do now is make sure that we set up the Linkerd on the infrastructure, and we tell Kubernetes, and obviously it creates a namespace in the Kubernetes. It installs all the objects which is required, and then we are ready to go with Linkerd. And but Linkerd knows there is set of pods which are running, but it really does not know which of those pods it needs to capture this information or provide these retry options and other things. So what we will do is, obviously after installing, we will also do one more check just to make sure it is all set. And you know I'll anyways come here, how we are going to set this up. Even before how Linkerd is set it up, we need to understand that uh, we also have to make sure that not all services require retry, right? Say for example, if you have a payment service, it does not really require a retry option, right? So it is basically you are you just try it once, and maybe you don't want to go back and again try payments service to run it again, right? So basically you have to create service profile, in fact, to make sure that which of the services needs to be retried. So this is where we are going to do stuff. So where we are going to tell tell the proxy, then nginx ingress controller, what are those set up the linkerd on top of that, and then we're going to run the deployment for the linkerd through proxy containers, and we will call the webhooks for these containers, and then we're going to set it up. So let me go back and see if this health check has done. We'll come back here again. So yes, we are all set. Let's go back. um, let's install let's install linkerd.
Yeah. So if you are trying this on your own, like without this, module, just be sure to, install the Linkerd CLI, because that's what it is required to do it. So as part of the configuration of this module, we install the Linkerd version that we needed for it to run it. So that's why. I mean, you may see some deprecations and things. So those are warnings, so it should be. You can simply ignore that for now. We will update the modules as and when it just it's needed to be updated. So, but if you see these warnings, just ignore them. Yeah.
So I've just rerun the check, so just
Mhm.
to see what all things has been installed from a Linkerd perspective. It is just making sure all the things we have installed, all the objects we have installed on the Kubernetes cluster is up and running for Linkerd to be used in our configuration files, right? So it's basically checking for the pods being up and running. So if you see here, it is waiting for the pods to come up, and it is all coming up now. So couple of things. That's it. So if you see, all the more important things which are required
You
to
can
run the linkerd is
y-
up and running.
can you do a kubectl get pods from the
Yep.
namespace Linkerd and then see maybe.
Yep. There are three
So
things which are running.
cool. Um, okay, I'll take a quick question again. Meanwhile, I think Vivek, if you want to run any script, you can go ahead and do that. So what's
Yeah.
next?
So what we are supposed to do next is to make sure we configure the app, which so basically we want to make sure the coupon service. Coupon service is the app where we want to add this retry policy, and then we'll create a service profile for that. And you see this annotation which is required,
Mhm.
which is supposed to be applied on the coupon service, where where the Helm charts are there, and from a deployment perspective, this is nothing but you're calling a webhook, for Linkerd, where you're injecting a webhook, in fact. So it's basically going to create containers while you run this pod. So let me go
Yeah.
back here and
Vivek,
make those
just one
changes.
second. One second. Just go back and copy the entire line. I'll tell you, because you're doing YAML and tabs and spaces are super important. So what you do is don't copy from there. Copy the entire line from, like,
From here.
yeah, yeah. So
No
go
worries,
from the
I
enable
got that.
part, yeah,
Yeah,
and
yeah.
then paste it on that thing. So that's the trick to paste the YAML
I
files
know.
correctly.
No, no,
Um,
got it. So
yeah,
it's in the coupons and templates. I hope
and
I'm in the
deployment.
right path.
Yeah,
Coupon template, yeah. And go here to the templates and make sure I
and
copy
then go
paste
back all the
this.
way. No, no,
No,
no,
this
no.
is wrong.
Control
This
Z.
has to be on the lab. That's
Yeah,
correct.
yeah. The other trick that
And
I do is I go on the end line and just go all the way behind and then paste it, so it'll be the correct indentation. So if you are wondering what we are talking about here, is basically the
indentation.
indentation is very, very important for YAML. VS Code has some really interesting plugins to help you with it, but since you're editing on the code editor online, um, it's good to know these tricks. Yeah, thank you, Eco. Little tips and tricks like that are so helpful. Yeah, absolutely, and that's why we do this live, right? So that you can see us fail and then see us how we're gonna how we recover this from this, right? Um,
I mean, by the way, we
thank
have
you for that.
failed while testing this out. That's why we know this.
Yeah,
Done. This is right.
right.
Cool. So we are done with that. And this is already there. I just need to, I think it's
Yeah.
already there in
So we're
the
just
service.
adding
Oh,
annotation to the services so that
yeah.
it's Kubernetes is aware of
Let
the
me talk
linkerd.
about the
Mhm.
where is linker D and service profile.
Yeah.
So most important thing here is the budget, right? So it's
Mm.
basically the retry policy which you're adding here. There could be a lot of things, right? So if you add a dedicated number, in say for example, try for 5 or try for 10 times and then fail, uh, even with the volume and the exponential strategy or the policy which we had, if there is a lot of requests coming into the service, it still might it still might hurt the service which is taking the incoming requests. And the incoming request service which is getting the request, it will still fail because of the load which it's getting, right? So that is something which needs to be taken care. So this is the advantage of building on the infrastructure side, where you're making sure that it's only the 20 times more uh, load of whatever load you're putting, you can apply on the service where they where you are trying to run this specific retry, right? So this is where you can set it up, and also you can add a minimum retry per second is only 10. So that is
Yeah.
something which you can set it up, right? So
So
yeah,
yeah,
Nish.
this is more like an advanced logic of implementing this. It's not the circuit breaker and retry. It's more like you basically configure a budget like 20% of your traffic. When you has those failures, then you do what you need to do. Kind of like it's a kind of like it's more like configuration driven that way, and it's basically applied to the path regex you provide here. You see that coupon API. So you can actually provide any regex. So if you may be connecting to an external service, so you can provide that. So whatever profile you provide here, based on that is what linkerd looks at it and then applies retry logic there. And you can also see another variable there is retriable true, and that needs to be true to make sure this retry budget comes in play, right? Yeah, go ahead and apply the service profile.
Yeah, I'll just apply the service profile.
Yeah. So basically, we added some annotations and then we applied the service profile, right? So
Yeah.
this will ensure the service mesh is aware of what configuration it is looking at
Yes.
to create the retries.
So this gets interesting. So, Linkerd does not have on-the-fly ingress, right? Ingress management, right? So it basically uses the already existing ingress controller, right? Which I mean, we have in Nginx in this particular example. So we have to tell Nginx that, okay, add Linkerd as one of the profile to your your services, right? You have to find this ingress, right? So we just need to copy this as well and just add this one in the ingress as well.
Yeah. So
It's also
basically,
an
those,
annotation.
yeah, for newcomers, again, ingress is nothing but an object in Kubernetes that basically understands how does it take traffic into your cluster. So that's a configuration. So any kind of input that comes through it, it comes through the ingress. So basically, that's where he is configuring the ingress controller where these values are applied. So these are like minor changes that you need to make. So again, these are infrastructure changes. They are not code changes. So remember that, and that's a key thing here. And they're all configuration driven. So it can be a Node.js app or Java app. It doesn't matter. So these configurations remain the same for any app. Okay, looks like it did it
That's,
correctly.
yep,
Mhm.
that's done. And all
Now
we
you
need
can
to
go
do
and
is
deploy.
to just deploy this. Let's go back and deploy this.
Yep.
And you see we are deploying all the three changes which we made, right?
Mm-hmm. Yep. So basically, whatever charts were changed, those are reapplied. So while you're doing that, I'll just take that quick question. So we have a question on what strategies are recommended if something cannot fail to process. Retries and circuit breakers in Poly are helpful, but even a queue service local storage buffer might go down. Okay, the question is basically, I think it's understandable on the retry part and circuit breaker policies for HTTPs. Probably, I think the request, I think you're asking about what if a queue service or a local storage or something will go down. So the Poly library that it also comes with this logic on wait and things like it's not just HTTP. It could be anything. It could be a method retry as well. So you can configure it that way for those aspects. And you can see that we are using infrastructure based one, and this will apply also to other infrastructure based queries and things like that. And if you're looking specifically on the Azure side of things, I'm going to paste a URL here where I think the moderator can paste this back into the stream. It's basically there is some Azure best practices on retry specific to certain services. So if you're using certain SDKs and other things, some of them have built-in. For example, if you're working with SQL Server and Entity Framework, you're using, there is built-in retry mechanism that you can use as well. But if you're using other services, you can also look at that. So I actually pasted one link, so which will come into your comment section. So you can take a look at that and know how what are the best practices for these things. And again, Poly as a library, kind of like it's more like a it does have a templates for how you can do it. So you can wait and retry could be anything. It need not be HTTP. It could be anything else, whatever you depend on, whether it's local storage or cache or file system or whatever. Like you can apply that. What's up?
I'm
What are
waiting
you trying
for
now?
the health check. Health check.
Okay, cool.
So
So you
I'm just
applied
waiting.
everything on the Linkerd side of things, right?
Yep,
Okay.
I have applied everything.
Can you do kubectl get pods and let's see where the container status
Yep.
is?
No, it's all up.
Okay.
It's showing up. Yeah, in the previous execution itself. kubectl get pods. It's all up. If you can
Okay,
see
they're all
here,
running.
coupon is having two because
Mm.
there are linker Ds.
They have to be two of
Working.
two, not one of two. So they're just
Yep.
waiting to come up.
Yep. Oh yeah, two of two. Yeah, it has to come.
Yeah, so it needs to be up. So it's still working on it. So basically, you can see that when you have sidecars running, you will see two pods instead of one, and that's what we are actually clarifying that it's not one of two, it should be two of two. So both your pods have to run. So now it should be two of
I
two.
think now it should be up. Yep.
Yeah, now
Now
it's all
let's
up.
see. Oh
Yeah,
yeah,
there you go.
now
It's two of two.
it's up. Two of two and two of two. We are all go
So
set.
these are the two places we implemented a service, a proxy basically, or the sidecar, and that's why
So
you
let's
can
go
go ahead
check
and
out.
implement for all the services. That's the right way to do it. Yeah, go ahead and
Yeah. So let's go
yeah.
and use this
Hmm.
fail file and see what happens now.
Yep,
So it
apply.
fails.
No, it just configures
and
right now. Yeah.
and
So
then I'll say apply. It just goes through, and if you go to this, see, it has gone 5 times. There is a issue. I mean, like it's trying for the 5 times, and then it's
apply.
throwing the message. But for user, it was seamless, right? I mean,
Yep.
you didn't really, from a user perspective, he didn't even know there was a partial failure at the back end.
Fantastic. So
So that's
that
how
was
this worked.
super simple,
That
right?
was super fast, right? That was super fast here.
Yeah, that's because
Yeah.
your retry logic is written that way. It's you're given a few seconds, right? So that's why it's faster. But
Cool.
the real thing to do is to slow it down. Don't make it fast because you
Let's
can hit into denial of service as well.
now
Mhm.
let's go to the most interesting part. The
What's that?
That is the
Mhm.
knowledge check,
Oh, right. Yeah.
right?
Absolutely. So if you have questions, please. By the way, we have completed the module and we have shown both the side of things, by implementation using Poly and implementation using an infrastructure uh, based resiliency. Okay, let's just pretend that nothing happened there.
Yep.
So the question, the question that we have here is, what's the primary goal when implementing a resiliency solution for an app? So aka.ms/polls, please go ahead and visit that link so that you can answer these questions. If you had paid
There's a
attention on
QR
the
code.
screen, you know the answers here right away. Was that? Yeah, that's a QR code as well.
Yeah, there's a
Uh,
QR code as well, by the way.
right. So the poll is,
So
what's
you
the
have to go to
primary
that
goal
link
of
to
implementing?
answer, right?
Yeah,
Yeah.
you have to go to
So
the
what's the primary
aka.ms.
goal?
Mhm.
So what's the primary goal, Nish?
Okay, let's read the options here. Make the app error free, handling user errors transparently, handling transient infrastructure failures, handling major infrastructure failures. So make the app error free is a developer dream, which never works. So it's pretty sure it's not that A. Um, so feel free to send us your answers. Handling user errors transparently, or handling transient infrastructure failures, or handling major infrastructure failures. So we have votes coming in for us, and the answer is handling
Transient.
transient infrastructure failures. 100% of you voted on the C. So fantastic, great going. So wonderful job. Thank you so much for sending in your responses. It just keeps us motivated that we are doing a great job. All right. So the next question then,
Which of the
which
following sentence is correct?
yeah. Okay, let's do this. Poly is the best option to handle failures, but it requires a significant amount of work. Linkerd can be implemented with little effort, but it only handles TCP connection failures. Or C, Poly and Linkerd can have complementary roles depending on the context, right? So everybody, let us know
There should
what
be.
is the right answer. Yeah. So what do you
It's.
think, Vivek?
I mean, we did talk all through the
Yeah.
session on only on those two items, right?
Yeah, it has to be depends, right? The answer whenever you have something called depends, that should be the answer. It's depending on the context. That's right. I mean, jokes apart, they're complementary, so you can mix and match as well. So cool. Do we have more questions?
Yep.
And by the
So,
way,
which of
hundred
the
percent of the
following?
votes. By the way, 100% of the votes did go to the C. Oh, sorry, 50% of. Okay, 50%. Okay,
Okay, which
cool.
is okay. It
Okay, what's
always
the correct?
depends. It always
Yeah,
depends. So,
yeah.
which of the following components isn't needed to achieve a resilient app in Kubernetes?
Mhm.
Interesting. CI/CD pipeline. I don't really think so. We need to have that. Uh, oh, I did
Health
read
check props for
through.
services. You need that
You
for.
do require that. You require
Yeah.
that. And failure handling code for complex database transactions, we need that too. right?
We need that too. Yep.
And network related resilient infrastructure, we might need that one too. So
Correct. Yeah. So yeah, we you saw us do the entire demo without any CI/CD pipeline. So what is most important here is to, from the resiliency point of view, is to understand what are the infrastructure issues, and so health monitorings and things like that is super helpful. Okay. So
th-
what's the next
this is
question?
interesting. This is an
Mhm,
interesting question.
mhm.
You have to
Wait, Vivek, one
it's
second, one second. Let me see how many people answer the previous question, right? Okay, so that's 66.67% of the people answered the right answer there. Fantastic. All right.
this one is pretty interesting, Nish, because
Mhm.
it's a game of words, because
Okay.
it's a which of the following statement isn't true of Linkerd. Okay, it's
Okay.
isn't true. Okay,
Isn't true. Okay.
it can adjust retries and timeouts adapting to the current cluster state. Uh, might be. It can monitor the traffic between pods. It can. Nish? It does. It must
Hmm.
be included in the app's code. Uh, it monitors all incoming and outgoing connections. Which one,
Right.
Nish?
So yeah, I know the answer. So yeah, I can see that most of them are doing the right answers. Yeah, it is a C. It's again play of words. It isn't true for Linkerd, so you don't have to do any kind of app code, like no app code changes at all. Whatever you saw us do, we reverted back all those code changes, and then we only applied configuration changes, which comes on the infrastructure side. So the advantage of service mesh, and for example Linkerd in this case, is that you have these kind of like you can monitor the traffic between the pods. That's something which we didn't show, but you can have a Grafana dashboard, and then you can see how these things work. um, it can monitor incoming and outgoing connections and things like that too, right? Okay, so now we have the next question. Which of the following statement isn't true? Again, is not true of Poly. It can handle retries with exponential backoff. It can ensure resiliency for complex database transaction. It doesn't require app code changes. It must be configured via code for every HTTP client. So go ahead and send us your responses there. Question is on Poly. Remember something which we write in code. So it can handle retries with exponential backoff. That's true. It can do that. It can ensure resilience for complex database transactions, and it doesn't require app code changes. Um, it does require app code changes, right? So
We did a lot of changes,
we
right?
did a lot of changes. So it should be C.
Yep.
And yeah, so we have also responses coming in, so successfully on the C. Yeah. All
Cool.
right. So
Let's
yeah,
summarize.
Vivek, so what did we do?
We did see two kinds of resiliency, from a code and from an infrastructure. And we used a Poly to build that code, and see how we can make sure that we can apply a couple of policies on top of your app to make sure that user is not feeling user don't see the issue when such partial failures happen. And then we did infrastructure based resiliency with the Linkerd, and we deployed everything back to the Kubernetes cluster. So that's what we did today, and pretty interesting learn module.
Yeah.
If you want to give it a try, just go there and
Yeah.
take a
So
look at it.
yeah, also you let us know how these modules are helping you. Go ahead and give it a try. I think one thing um, we wanted to be sure when you wrote this module was to make sure that nobody have to have any kind of development environment set up to do this. They should be able to come in, log into a browser, and do everything. You saw us do that. Yeah, of course, it has those disadvantages of we don't have a great like IntelliSense support and other things like that. But I think those are minor. But it's a great learn module. Just go ahead and check this out, and be sure to answer those questions on your badge. Thank you, Tarun, for letting us know. It was a great session. And All right, and I think also the one thing to remember is, this is part of a series of microservices presentations. So we covered a couple of them previously, and there's more to come. So the very next one being, instrumenting. Can you go to the next slide? Um, ins- uh,
That's my
uh,
favorite topic.
yeah, it's the instrumenting a cloud native ASP.NET Core microservice, where you will see some more dashboards and things like that, how you can, uh, you know, monitor and things like that, and what code changes you need to do. It's really interesting. So be sure to check them out. It's next week, same time. So be sure to join us. And anything else, Vivek, before we sign off?
Nothing else from my side. So I'll be there next week too. So
Fantastic. And
that's because that's my favorite topic. So I'll be definitely be there and talk about all the application insights, Azure monitoring, and obviously Azure monitoring for containers, which is a very interesting topic.
fantastic. So be sure to check that out. And we will be on the chat for some more time. So you can ask your questions. We will be happy to answer them. But otherwise, we're signing off. And thank you so much for joining us. Bye bye.
Bye bye.